Imagine for a second that you're on a movie set. You're the director, right?
Oh, okay, I'm with you.
And, you know, you don't know how to wire the Klieg lights. You certainly didn't build the incredibly complex RED camera they're shooting on.
Definitely not.
Right. And you probably couldn't, like, stitch together the period-accurate costumes if your life depended on it. But despite all of that missing technical knowledge, you hold the ultimate power over the final cut. You're the one who dictates exactly what that final shot must be.
Yeah, because, well, the crew executes the technical tasks, but the director holds the vision.
Exactly.
You don't need to understand the physics of the camera lens to know where to point it.
Now, drop that exact dynamic right into the middle of the hyper-technical, just relentlessly cutthroat world of Silicon Valley hardware and software development.
Oh, wow.
Right. Today, we're unpacking a really fascinating set of notes and scripts for this deep dive. They're titled The Ghost in the Machine: How to Manage Tech Giants Without Writing a Single Line of Code.
It's such a wild transition to read about.
It really is. We're looking at this insider case study of someone who transitioned from running raw operations in, like, the trenches of Cambodia, all the way to the high-pressure, sterile clean rooms of global tech. And here is the central paradox we're going to explore for you today. How does a person who doesn't write code, who, like, never even touches a code repository, end up holding the power of life and death over a major tech product?
Well, I mean, it challenges the most pervasive myth in the entire tech industry, right?
Which is?
We're conditioned to believe that the only people who truly matter are the developers. You know, the ones actively writing the syntax.
The coders.
Exactly. But these sources pull back the curtain on a completely different kind of power. We're looking at the absolute highest levels of technical project management, or TPM.
Okay, TPMs.
Yeah. And to understand how a non-coder actually survives in this ecosystem, we first need to look at the battlefield they're dropped into.
Let's set that stage, because the sources describe a work environment that sounds less like a typical tech campus and more like, I don't know, a corporate war zone.
It absolutely is. It's a massive clash of cultures and financial incentives. The source material lays out this fundamental friction between two colossal entities.
Okay.
So on one side, you have a global manufacturing powerhouse. Think of the massive factory cities in Asia where the physical devices are actually built.
And their primary motivation is what exactly? Just like keeping the lights on.
Oh, it's far more than that. Culturally and structurally, they are obsessed with yield and efficiency.
Yield, okay.
Yeah, their entire business model relies on churning out millions of units as fast and as cheaply as possible. I mean, if an assembly line stops for even 10 minutes, they are bleeding millions of dollars.
Wow. 10 minutes.
Right. They want predictable, repeatable, unstoppable momentum. That's all they care about.
Okay, so that's the unstoppable force.
And then you have the immovable object, right? A hyper-demanding, Seattle-based tech giant.
Oh, right.
And the tech giant doesn't care about the factory's efficiency problems or, you know, their profit margin.
Maybe with their client.
Exactly. The tech giant cares about perfection. They're selling a premium brand. They want a product that feels magical. A flawless user experience with absolutely zero tolerance for error.
I mean, they're famous for it.
Yeah. They will gladly halt a production line if, like, a single pixel on a screen is rendering a microsecond too slow.
So the technical project manager, the TPM, is just dropped squarely into the crossfire of these two behemoths.
Directly into it.
You have a factory trying to sprint and a client demanding they examine every single pebble on the track.
Yes. And the TPM is, well, they're the human shock absorber.
That sounds miserable.
It's intense. They have to reconcile the client who demands the physically impossible with the factory that just wants to ship the product and go home.
I mean, I get the stakes, but frankly, if I'm a senior engineer at the Seattle tech giant or, you know, a hardened floor manager at the manufacturing plant,
Right.
Why would I listen to this TPM?
Right, that's the big question.
If this person doesn't even code, they literally don't speak my language. It just seems like a recipe for getting immediately eaten alive by the technical experts on both sides.
And that is the most logical assumption to make. Like, how do you lead a room full of people when you can't do what they do?
Yeah.
Well, the source material provides a brilliant, counterintuitive survival strategy for this exact scenario. It's a concept the author calls black box logic.
Black box logic. Okay, walk me through the mechanics of this. How does treating something like a black box keep you from getting sidelined by these senior engineers?
So the core philosophy is that the TPM treats the complex technology entirely as an opaque container, a black box.
Okay, so you can't see inside.
Right. It's not about popping the hood and watching the gears turn. If you're the TPM, you don't need to understand the intricate syntax of the code base or the microscopic tolerances of the motherboard.
Right.
Instead, you rigorously, relentlessly define exactly what data goes into the box and exactly what behavior must come out of it.
Oh, okay. Let's test that with the restaurant analogy from earlier.
Sure.
If you're dining at a Michelin-star restaurant, you don't march back into the kitchen and tell the chef what temperature to sear the Wagyu beef, right?
You don't, because you don't have the culinary skills to back it up. And honestly, if you tried, you'd ruin the dish.
Right. But you still control the kitchen.
Mm-hmm.
You define the input, which is your order, and you evaluate the output, which is the final dish. If it tastes wrong, you send it back.
Exactly.
You're controlling the entire operation through logic, not execution.
But here's my question. In the tech world, when the quote-unquote dish comes out wrong, an engineer opens up the code to find the bug.
Yes.
If the TPM doesn't touch the code, how do they actually fix the problem?
And that is the crucial distinction here. The sources explicitly state the TPM doesn't debug the code. They debug the business flow.
Debugging the business flow. Okay, what is the actual mechanism there? Like, what does that look like on a Tuesday afternoon when a product is just completely failing?
Okay, let's trace a failure to see how it works. Imagine the camera module on a new prototype phone is constantly crashing. Okay.
A software engineer is going to dive straight into the firmware, right? They're looking for a memory leak or a missing semicolon.
Right, they're looking inside the box.
Yes. But the TPM steps back and looks at the flow of information that created the box in the first place.
So they're looking at the pipeline itself.
Precisely. The TPM asks a totally different set of questions. They ask, did the tech giant change the software specifications late in the game?
Oh.
Right. Did the procurement team as the factory source a slightly cheaper adhesive for the camera lens that, I don't know, shifts under high temperatures?
Wow.
Or was the requirement accurately translated between the English-speaking designers and the Mandarin-speaking factory floor?
I wouldn't have even thought of that.
Exactly. The TPM is looking for the failure in human communication, supply chain, or project scoping. They are fixing the system that produces the code rather than fixing the code itself.
You know, there's a really striking metaphor used in the notes here to describe this. The author says the TPM is the architect of the logic, not the bricklayer of the code.
It perfectly captures the dynamic.
It really does.
The architect holds the vision of how all the systems, you know, the plumbing, the electrical, the structural load, how they all interact with one another.
Yeah.
The bricklayer is focused on the perfect placement of one single brick at a time.
Sure, an architect designs the house. But if the bricks are crumbling because of a bad clay mixture, the blueprint is kind of useless, right? Doesn't the TPM eventually have to get their hands dirty to understand why the bricks are failing?
Well, they need to understand the properties of the brick, but they still don't need to mix the mortar.
Ah, okay.
Right. They just need to know that this specific brick can't hold the weight the Seattle tech giant is asking it to hold.
Right, right.
Which kind of leads us to what happens when the inputs and outputs completely break down. Because defining the flow is great when things are working. But what happens when the box breaks and both of these giant companies just start pointing fingers at each other?
Right. Like when the factory says, this input is physically impossible to manufacture, and Seattle just says, figure it out. Who breaks the tie?
That's exactly where the TPM has to stop being a manager and start acting as a simulation.
A simulation.
Yeah. The source material calls this becoming the digital twin of the entire operational process.
Okay, let's pause on that term for a second, because usually when we hear digital twin in tech, it means like a virtual 3D model.
Right, exactly.
Like a digital simulation of a jet engine that you run stress tests on before you build the physical version.
Right, but in this context, the TPM themselves is the simulation.
Wait, really? The person?
Yes, they have to hold a complete dynamic model of how the entire business works right in their head.
Wow.
They need to be able to accurately simulate how the Seattle executives will react to a delay, how the factory floor will react to a design change, and how a software patch will impact the global shipping schedule.
That is a lot to juggle.
It is, because when things break, their core job is to translate hard engineering limitations into actionable business solutions.
Okay, I need a concrete example of this because it sounds incredibly abstract.
Yeah.
How does a person act as a simulation during a crisis?
Okay, let's look at how they handle QA logs. Quality assurance.
Okay.
Now, normally a QA log is just a JIRA ticket assigned to a developer. It's a bug report that basically says component X fails under condition Y.
Sure. Standard stuff.
But in this high-stakes crossfire between Seattle and the global manufacturer, the sources note that a QA log stops being a technical document. It weaponizes.
It weaponizes.
Yeah, it becomes a highly sensitive political document.
Because every error on that log translates to millions of dollars in lost time.
Exactly. The tech giant looks at the raw QA log and reads it as, your factory is incompetent, you're failing our perfection standards, and you're violating the contract.
Oh.
But the factory looks at the exact same QA log and reads it as, your Seattle engineers are living in a fantasy world. Your designs are physically impossible to manufacture at scale, and your specs are broken.
So a simple bug report instantly turns into a diplomatic incident between two warring empires.
Yes. And if a TPM just blindly passes that raw QA log from the factory straight over to the client, the sources warn it will trigger a full-blown corporate meltdown.
They just throw it over the fence and chaos ensues.
Exactly. The TPM has to act as the ambassador. And this is where being the digital twin comes into play.
Because they can simulate the explosion before it happens.
Yes. They look at the QA log, and because they understand the business flow, they don't just see a failed component. They see the political fallout. So before that report ever reaches the tech giant, the TPM translates it.
I want to dig into that translation. The sources mention a specific, really high-stakes scenario regarding casing sickness.
Oh, yes.
Let's unpack that because I think it perfectly illustrates what you're talking about here.
It's a fantastic example of the digital twin in action. So imagine a prototype run for a new flagship device. The Seattle design team wants a ridiculously thin outer casing.
Right.
It's part of their magical vision. But on the factory floor, the injection molding machines simply cannot push plastic that thin without a massive failure rate.
It just snaps.
Yeah, the plastic cracks. Yield plummets to unacceptable levels.
So the factory manager is sweating because the machines are jamming and they're losing money every second, while the Seattle designers are just refusing to compromise their artistic vision.
Exactly the stalemate. So the factory logs the QA error, design out of spec for mass manufacturing.
Uh-oh.
Right? If Seattle sees that, they'll threaten to pull the contract. So the TPM steps in. They don't try to rewrite the factory's robotic arm code.
Right.
They don't open the CAD file to redesign the phone. They use their mental simulation to do the math. They realize that if they add just 0.1 millimeters to the thickness of the casing, the factory yield jumps to 99%.
But Seattle wants it paper thin.
True, but Seattle also wants to hit their massive holiday launch window.
Oh.
So the TPM takes this engineering limitation and translates it into a business choice. They go to the Seattle executives and say, look, we have two options. We can keep the current thickness, but we will miss the holiday launch by 3 weeks.
Which they would never do.
Never. Or, the TPM says, we can increase the thickness by 0.1 millimeters, which is completely imperceptible to the human hand, guarantee a 99% yield, and ship on time for the holidays.
That is brilliant. They didn't argue about the tensile strength of the plastic.
Not at all.
They argued about the launch date. They basically solved a political problem disguised as a technical error.
They managed the business flow. And recognizing the TPM as this high-level diplomat, I mean, it really shifts our perspective on what makes someone valuable in this industry.
Yeah, it completely changes the paradigm.
Suddenly, the fact that they don't know how to code doesn't look like a deficit at all. In fact, the source material argues it's the very thing that makes this ghost in the machine so incredibly powerful.
That brings us to the core superpower of the quote-unquote non-typical professional. The tech industry worships hard skills. We see it everywhere.
Oh, absolutely everywhere.
Every job posting demands a laundry list of programming languages. If you don't know Python or React or C++, the culture basically tells you that you have no authority.
But this case study proves the exact opposite. While everyone else is lost in the weeds obsessing over the what and the how, true authority comes from commanding the why.
The why?
Yeah, because the non-typical TPM isn't focused on the placement of a single digital brick. They're the only person in the room who can actually see the entire forest.
They can see how the factory's yield quotas interact with the tech giants' marketing deadlines.
Yes, the sources put it beautifully. They aren't just managing a project, they're managing the integrity of the vision.
Integrity of the vision.
They ensure the product actually survives the perilous journey from a whiteboard in Seattle through the brutal reality of an Asian manufacturing plant and into the hands of the consumer.
I mean, I see the value, but I have to push back on the human element here for a second.
Okay, sure.
The psychological toll of this role must be staggering. Think about the imposter syndrome.
Oh, yeah.
You have to walk into a conference room full of senior engineers who have been coding for 20 years, and you basically have to stand there and say, I don't know how to do your job, but I know how your job fits into the universe better than you do.
Yeah, that's tough.
Right. How do you possibly hold your ground when someone inevitably tells you that you aren't technical enough?
It is a daunting position. I mean, you're stepping into an arena where the default currency is technical prowess, and your pockets are completely empty of that specific currency.
Exactly.
But the source material gives a definitive, really striking answer to this exact challenge. When a senior engineer tells you that you aren't technical enough, you do not try to argue with them about technology. You show them the ROI of your logic.
A return on investment.
You prove your worth through outcomes. Engineers are, at their core, deeply pragmatic people. They respect systems that work.
That's true.
If your black box logic prevents a diplomatic meltdown over a QA log, they notice. If your understanding of the business flow and your 0.1 millimeter compromise saves the company tens of millions of dollars in factory downtime.
And saves the holiday launch.
Right. That is undeniable ROI. You don't need to write the code if your logic is the only reason the code ever reaches the market.
You don't argue tech, you argue outcomes. That is an incredibly empowering perspective for anyone who feels locked out of the tech world.
Definitely.
So let's bring this all together. We've traced a remarkable journey today, starting from the raw operational trenches in Cambodia to the absolute highest levels of global tech. We've seen how to survive the crushing grind between a manufacturer demanding efficiency and a tech giant demanding perfection.
And we've uncovered that the key to surviving that crossfire is embracing black box logic. You command the technical output by strictly defining the inputs and outputs, and when things break, you debug the business flow rather than the code.
Right. And we also explored the mechanics of becoming the digital twin of the process. How you have to step up as an internal simulation, acting as an ambassador to prevent raw QA logs from turning into corporate warfare.
Yeah.
You become the translator who turns a factory's engineering limitations into a client's business solutions.
It all culminates in the realization that being a non-typical, non-coding professional isn't a weakness. It's the superpower that allows you to step back and manage the integrity of the overall vision.
So, to you listening right now, whether you are in tech, healthcare, finance, or construction, there is a profound lesson here. You don't need to be the developer to own the future.
No, you don't.
You don't need to be the one tightening the literal bolts or writing the syntax. You just need to be the one who understands how all the pieces fit together.
Yeah.
You need to be the architect of the logic.
And that leaves us with a final, highly provocative question inspired by these sources.
Lay it on us.
If the true ghost in the machine is ultimately a master of logic rather than a writer of syntax,
Right.
what happens next? Right.
As machines and artificial intelligence get better and better at writing the actual code themselves, the value of the bricklayer is going to plummet. When AI can generate the code in seconds, will the non-technical architect of the logic, the person who can see the big picture, simulate the business flow, and define the black box, soon become the single most vital person in the tech industry?
It's a fascinating thought to mull over. I mean, the entire hierarchy of the tech world could just flip upside down.
It really could.
Because at the end of the day, whether you are managing a massive global hardware rollout or directing a blockbuster film, the people who build the cameras will always need someone to tell them where to point the lens. Keep that in mind the next time you walk into a room full of experts. You might just be the ghost they didn't know they needed. Catch you on the next deep dive.